In the figure above, triangle ABC is similar to triangle EDC. That's what this symbol stands for, similar to. Which of the following must be true? Note the problem says that the figure is not drawn to scale. So what does this mean? It means we can't just look at the picture and make any determinations about angle sizes relative to other angle sizes, length of segments, anything like that. We have to use just the information given to us in the problem, which is that ABC is similar to EDC. So what does that tell us? Well, number one, it tells us that the corresponding sides, so for example, AC and CE and BC and CD and AB and DE, those corresponding sides are in proportion to one another. That doesn't seem to help us much here. But what's more important is that the corresponding angles in these two similar triangles are equal. So of course these two are equal because they're vertical angles. But in addition, this angle would equal that angle, they're corresponding, and this angle would equal, we'll use a different color here, green. This angle equals this angle, right? Because they're corresponding angles. And that's what makes them similar triangles, that their angles are equal. So what does that tell us? Well, notice we have two lines, and then we have this line, for example, cutting through them, and the two angles that are, we might call them alternate interior angles, are congruent. So if those two angles are equal, what does it tell us? Well, it tells us that these original vertical or horizontal lines here are actually parallel. And indeed, if we cut these lines by this transversal, call that transversal BD, we see again we get two alternate interior angles that are congruent. So again, just another proof that these lines must be parallel. So we go to the choices, and that would be choice C. Note that these lines don't look parallel, right? They, in fact, if we extended these farther in both directions, they would actually eventually intersect over here. But that's because, again, we can't trust the picture. The picture's telling us it's not drawn to scale, so we can't look at this and say, oh no, they can't be parallel because they don't look parallel. Well, exactly, they're trying to trick you. So you have to actually look at what they give you and deduce that they're parallel from the angle relationships. This one reminds me of some of the tricks that they would pull on the old SAT, particularly with this figure not drawn to scale part. So it seems like they're going to repeat that again, and the lesson is the same. While there'll be less geometry of the type that we saw on the SAT, on the old SAT, on the new one, when they do provide these plane geometry questions, they're going to probably use a lot of the same tricks. So that's something to keep in mind. Otherwise, though, a little bit more reliance on understanding what exactly similar triangles are. There is some of that on the old SAT, but perhaps it's something that will be a bit more in depth on this one. But otherwise, parallel line relationships with angles, pretty standard. Nothing here is too crazy. It's just the issue is if you remember it. If you remember the relationships between the angles that give you parallel lines, if you remember the consequences of similar triangles, that's the challenge of this question.